GPL How2F. Okay, I have a cold, so you have to bear with me. This is old Disk 1B animation. This will be on the package. This is a TI basic program that just does an animation. It doesn't do anything else. It's just an animation. I wanted to show you how to take a TI basic program and convert it directly over to GPL. Now, I can't go through step by step on the entire thing, but I can show you basically what I did, and then the package explains basically everything you can think of. I tried not to miss anything to explain how it works and what it does. The program doesn't do much, as you can see, and the entire program is a listing right here. It's not very big, only 450, so it's 45 lines long. Now here I've went into the editor. I use the RAG editor instead of the editor assembler editor or funnel web. There's a couple of reasons why I do this. The nicest thing I like about it is the back key doesn't kick you out of it, and you have to type in the name of the file, but other than that I don't have that problem with it. So you can see the program is very small, and now that I've got it in the editor, let's start putting in some GPL. What I'm going to do is I'm going to use G160 for the GPL commands to say the same line as the TI basic program. And then I'm going to space it out, and then I'll put star. An asterisk or a star is in GPL means a comment. So anything after the star is ignored. So I can't make a direct call character in GPL because it didn't have one. So if I make a data statement with that value of the FFs there, I can make my own GPL command to move that data into VDP. Now I had to space it out there. So 16, so 16 bytes, 4, 8, 12, 16. I'm going to move from D170, that's the line I called it, D170 up there at the data. And then it's going to be video at 48 times 8 plus 2048. Now 2048 is the address of where the character table is. But if you add that together, 8 times, 8 times it plus that gives you your value. So I put this in the comments so you can see it. Then we go to the next line. Now you can see that this is $$ equals. Now there is no $$ in GPL, so I'm going to make it into another data statement and do basically the same thing. And then of course I can do the same thing in the next statement, and I just keep on going. Okay, so a little later, here we go. This is the variables that I had to set up. I had to set up 2 variables. I only used 2 variables. Now imagine that your entire GPL, your entire basic program with only 2 variables in it. Well, this GPL program only has 2 variables. That's pretty remarkable for a program. So anyway, here's our header. GPL won't work without a header. I explained this in my other how-to GPLs, and it's going to be loaded at C000, and the title is going to be GPL How-to Basic to GPL. So these all explain them. Then we have our header linker. Now what that means is the link is the pointer. So it says data head link LK. Then head link says the next one, and then data G160 is the first line of the program. Then the string is what you're going to see on the TI title screen when you fire up GPL in a linker, or if you do it with just regular modules. So this is the program listing. Now I said that the number, star number, like it says star 100 rem, that's how it works. So in the basic strings, we've taken our data statements, converted them. Now we're going to go up here and we're going to start with the first of the program. There's our clear the screen. 32 is a space character. And then I had to add this line right here, G165, store 30 at RAN. RAN had an unknown value. In BASIC, it would start out at 0, but in GPL, it has an unknown value. So you have to set it up first. Then this is the line that we did earlier, which is the call character. 48 times 8 plus 2448 equals the address and character table. I have a cold, so I'm having a problem talking. Then we go down to the next set of lines. Now, 210 is 4x to equal 1 to 8. Now, in GPL, there is no command like that. There is a format command like that, but that's for just displaying on screen. There is no read in GPL, only a move or a fetch. And I already showed you the move. The fetch we haven't used yet. And there is no print line because there's no such thing as a print line. We have more like a display ad wherever you want on the screen. Now then we go to the format command. Now the format command is like a display ad. In other words, it sets up to write on the screen. It tells you we're going to write on the screen. And it works very much like basic, the row 16. Now how we're doing this is instead of the print command, we're going to use 24 minus 16 minus 8 equals 16 because there are 8 rows we're going to put on the screen. And these are the data statements that are originally in the basic program for 380. And all you did was converted it to a hex text, which is horizontal text line. And so the column 3, row 16, and I put that one there. And then I drop down one line. I add a 1 to it, to 16. And then I make it column 3 again. I keep doing this all the way down until I get to all 8 lines. And then I would put in a fend, which is end of format. F for format, end. So F, end. There is no next in GPL, so the next in GPL is ignored because we don't use it. Then we have a go sub. Now a go sub in GPL is the same as a call. So call in GPL is the same as a go sub in basic or extended basic, either one. We go up to our call characters. This is the same thing we did before. It's just that we used $. We're going to use the data statements instead. So we tackle the same problem. No matter what the problem is, we tackle the same problem of $, or $B$ or $C$ or a data statement in the same way with data. And we go to it. Now, a branch or branch on reset is the same thing as a branch, which is a go-to. If ran equals 2, well, we compare 2 is higher than ran. So it's pretty much the same. Now, the branch set says if it's set, then go to 340. If not, then ignores it. So it works like the if then. Then we have a call horizontal character. Here's another way of doing it. Store 32 at the address on the screen, which is 32 times 12 plus 2. That's the address. 32 is characters long for each row times 12 plus 2. Now we need a delay loop in GPL because GPL goes too fast. Basic goes slower, so the program would look very weird. It would just fly by. So we put a delay loop in. Now we go up to 330. Ran equals 30. And store 30 at ran. Pretty much work the same kind of thing. Now for this one, we used a different kind of H character, call horizontal character. And then we put ran into the XPT. Now XPT is our row and YPT is our column. So we put it into the row side and we left the column same. So row 12 is in YPT. And it works the same way. And then we went down to this one and we did slightly differently. We had to get a variable. So we put ran into temp, our temporary variable. Ran is our other variable. We decrement it, -1. Then we stored it into XPT, which is a row. And then we went into our format, put it on the screen. And then we went down to our row and we put 12 in. And then we put in for our, XPT was our column. I'm sorry, I messed up. So anyways, then we go, we're going to do another delay loop. Then we're going to go down to our ran equal ran -1, which is the same thing as just decrement at ran, -1. Works the same thing because ran doesn't have an equal. We don't need an equal. Then we return, end of program. Now we're just going to show you the delay loop that we added that we had to. It's going to be store 500 at temp. And it's going to call this 3 separate times in the program just to slow the program down. So it's going to be 1500. So it's going to count to 500 3 times in 3 separate places to slow the program down so you can see what characters are being put on screen. So how this works is it just decrements that temp. It puts 500 in it, decrements it, and it just loops. And then when it's done, it returns. And then that's the end of the program. That's it. It's 187 lines long. That's all the GPL program there is. And that includes all the lines for the other program, which is the basic program, which we originally started with. And then I commented on everything as it goes through so you can see what everything does and how it works. This is a listing of what we got on the disk. There's our assembler, our GPL assembler. You have to use that to assemble it. B animation is the basic program. C-save and C-save2 is to save GPL to a gram format. Edit 1 and edit and edit. And then we have edit 1. Edit 1 is the assembler version. And then edit is the RAG version. GPL Loader, GPL disassembler just for the fun of it. Then our listing for the file when we assemble it. And then our link and in utility 1 are our linker. Source is S animation, object is a O animation, and our list is a L animation. So next thing I'm going to have to do here is we're going to go in, we're going to assemble this program. Now I've already got it on the disk here, but we're just going to do it again just to show you the steps. Put in our source, our object, our list, and it's LCSFPF as usual. If you watch the other videos, then you know. Or the other GPL how-tos. Just so I can drink a coffee. My voice is drying out here. All right, so this is a directory. Now, this is a listing of what we've got, and we're going to go in and we're going to go to the animation we created with the linker. But now we're going to go to the GPL Loader. This is the program in GPL. As you can see, it moves considerably faster than TI Basic does. Here's the TI Basic version, again, just to show you. Considerably slower. The reason why is because the delays between it moving from one step to the next is because Basic's obviously slow. So once again, we'll go back and we'll load up the GPL. As you can see, the 500 loop doesn't slow it down much. Now, just for the fun of it, just for the heck of it, let's go into Classic 99 and load up the B animation. And let's speed it up and run it at the speed with the overdrive. Well, we'll put it in overdrive so it goes a little faster. And then after that, we can move into a little bit faster than that by going to the system maximum. And whenever I do that, I'm making the voice over after I've already made all these movies. So that's the reason why you see me wondering when it's going to come out. It's running system overdrive right now, I think, yeah. Because you can see it moving along pretty fast from next step to next step. Then I'll put it in the system maximum, hopefully, here. It's a bit longer than I thought it was going to be. Now, this is the GPL version without with the system overdrive on it. And I took out the delay loop, too. This is the reason why it wouldn't work very well. When you got it in overdrive or maximum CPU speed, and at the same time you're running no delay loop, you can't even see what's going on the screen. It's just jumping all over the place. Assembly would be much worse. This is where I've slowed it down a little bit. I've gone into just regular overdrive instead of maximum. And then at the last here, I'll move it into just regular with just a delay loop. Now the delay loops change from 500 to 1. So that's the reason why it's moving so fast here, is because the delay loop, the delay loop is still there, it's just a 1. It's coming from 1 to 0, then it's done. So I'm just dropping down a speed each time. Let me go back into maximum there. And I'm going to turn off maximum and go to just regular speed. And there it is. That's just regular speed with 1 as a delay loop. Okay, so there you go. I'll make more along the way. Have fun.